Today we're going to continue with our ideas of reaction rates. So how can we speed up a chemical reaction? So what we're going to do is start with a little review and think back to the virtual lab. What needs to happen in order for a reaction to take place? Think about collision theory and the 3 parts to collision theory for your answer here. Answer in a complete sentence. Once you're done, move on to slide 3. For slide 3, you're going to measure, looking at measuring reaction rates. So you're going to click on the video here and watch the video on reaction rates, and then identify 2 ways in which a reaction can be measured. So how can we figure if a reaction is fast or slow? What ways can we measure it? And answer in a complete sentence here in the blue box. Double click. For slide 4, question 3, think about what you've learned about concentration and temperature simulations. So in those, the concentration, as we added more particles, the reaction sped up. We talked about increased frequency. As the temperatures got increased, those graphs looked a little different. They increased until a certain point, and then they began to decrease slowly, the reaction rate. So for here, you're going to watch this short little video. It's a few seconds of hydrochloric acid, the liquid, and marble reacting together. You're going to answer, what do you observe during the reaction? So what do you see happening in the video here? So when you play the video, so what do you observe right now happening in this video here? What do you think those bubbles are? What do you think is happening to the marble? What's happening in this whole beaker here? So why is this considered a chemical reaction? So think back to last semester. What are chemical reactions? What means a chemical reaction is taking place? So think of properties of chemical reactions for 2. For 3, what do you think a more concentrated acid would do to the reaction rate? So like a stronger acid, what would that do to the reaction rate here? Would it be faster or would it be slower? And then for 4, what if you heated up the acid? How would that affect reaction rate? So kind of make a hypothesis here. You can do a little research on how heating up acids might affect reaction rate. Think about temperature. And so complete sentences for 1 through 4. On slide 5, we're going to use this chart to look at how a reaction progresses over time. And this is over 60 seconds. So number of molecules over 60 seconds. So if it's going from left to right, what do the purple circles represent? So here your purple is what you start with. Over here is what you're ending with on the right-hand side. So what is the purple representing if that's what you start with? What is the purple line showing? So over time, what we start with is going down. So we start with 50 particles of purple. At 10 seconds, we have about 23. At 20 seconds, we have 11. 30 seconds, we have 5 or 6 particles that are purple that are left at that time. So what is happening here? Explain what's happening here in a sentence for 5. What do the green particles represent? So we see green popping up. What is this green? It starts at 0 and it ends at 50. So what are these green? Think about a chemical equation. What would it represent if we end with green? And what is that green line showing? So as you see the green line go from 0 to 50, what do you see happening here? You can think about number of particles, what that means. When we go from purple to green, what's that representing? On slide 6, we're going to do a little experiment. So what evidence do you have from the beaker and the graph that a reaction occurred? So here it says, click here to open the simulation, run the reaction. So we're going to click here and it will open up our reaction. It says select run reaction, then select the variables. Choose control. So variables, we have our different variables here. It wants us to choose control and then to hit run reaction. So look on the left and here. We'll start it over one time. So look at the beaker. The line, as you see, goes up, but what's happening to the beaker here? So we're going from red and blue on our reactants, and then C, the purple, is our products. So this is a combination reaction. So what evidence do you have in the beaker and the graph that a reaction occurred? So explain what you saw, meaning that a reaction took place. On 7, you're going to choose temperature now, and you're going to look at that. Temperature, decrease, and run your reaction. And then you'll do it for increase also. So for variables, you go to temperature, increase. So here's your standard. If you run it, this is what happens if you increase the temperature. This is your new rate of reaction up here. So which line on each graph represents the control, the dashed or the solid? Which line represents the experimental condition or the variable changed? So does the dot or the solid line, which one represents if we've increased or decreased the temperature? Which one doesn't change? So looking at the same graph, we did increase. If we start over with decrease, this is where we change the variable. This is the line being created from the decrease. You'll see that this one didn't go to completion with a lower temperature. So determine, is this solid line your control or is the dashed line your control? And explain why here in 9. 10, which one represents decreased temperature? So you can say letter A represents decreased temperature because it took longer for the reaction to occur and the reaction did not complete. Does a decrease in temperature increase or decrease the reaction rate? So looking at A, does this make your reaction rate slower or does it make it faster if you decrease the temperature? Cite evidence from the graph to support your choice. So tell me what your answer would be. And then you would say, for example, or based on graph A, this happened. And you can also relate back to here when you look at the decrease and what happened in the beaker. For 9, you're going to look at an increase in temperature. So you've determined that A is your decrease. So which one is your increase? So you'll say this one is my increase graph. And then for 13, does an increase in temperature increase or decrease reaction rate? An increase in temperature, blank the reaction rate, because, and then cite some evidence from the graph. On the next section, you're going to use the simulation to look further at concentration, catalyst, and surface area. And then you're going to answer the following questions. So under variables, we have concentration, surface area, catalyst, concentration, and surface area. Those are the 3 we haven't done yet. So you'll still use this and just change the variables. So for these slides, it's asking which one represents a decrease in concentration. So you'll keep that tab open. You're going to go to concentration, decrease, and hit run reaction. Okay, now you see which graph is this. So this graph matches graph A. So graph A represents the results of concentration that is decreased. So a sentence here. And then does a decrease in concentration increase or decrease reaction rate? So determine what that would be and cite your evidence from your graph. 12, we're going to look at increasing concentration and if that affects our reaction rate. So you'll just go back to your tab. We're still on concentration variable. We want to hit start over at the bottom. And this time you want to hit increase. We've done decrease. You're going to hit increase concentration. So we have more particles in the same amount of space. And we're going to run that reaction. So think about the time it took from it to go from A plus B to the product of C. So blue and red to purple. So for this one, which one represents increased concentration and does it affect the reaction rate? Make sure to cite your evidence, especially from the graph that you choose. 13, so this is just notes about concentration here. So concentration is often described in units of molarity. This refers to how many moles of the reactant are dissolved in the solution, the liquid solution. The higher the molarity, the greater the concentration. So if you have 2 molar of sodium chloride is more concentrated than 1 molar of sodium chloride. So that's a saltwater solution. So 2 molar is greater than 1 molar in that saltwater solution. For 18 and 19, you're going to do catalyst the same as before on that app here using catalyst. So this is looking at just what does the catalyst do with or without. Surface area. So if you decrease the surface area, what would happen? If you increase the surface area, what would happen? For slide 16. So same as the other slides. Slide 17, you're going to watch how to speed up a chemical reaction and get a date. So after watching this, what are the 5 ways to speed up a chemical reaction? So we've gone over some of those today using this simulation, and the video will go over them. So this one you can just list the 5. What are the 5? On slide 18, you're going to watch this video and then answer, how does concentration affect rate? Complete sentence. Would a dilute or less concentrated solution have a faster or slower reaction? You would say faster or slower because why? How does pressure affect rate? So an explanation here. Why does increased surface area affect reaction rate? So you would put an explanation here. So there should be complete sentences in all 4 boxes, and you'll use the video to help you answer. Lastly, on slide 19, in this chart here, you have ways to increase the rate of reaction and how do they work. So with those, we have some word bank down here. So you can copy and paste, and it tells you how to do so in the word bank. So in this bank, this is ways to increase the reactions. You can take these, you can include them in the boxes. These are your 5 that you also had on slide 17. Then you have to match, what do those 5 do? Do they increase number of collisions? Do they decrease? Do they organize the particles in the direction they go? Do they make it so they have enough energy? What do these different factors do here? And that is the end of your assignment. Once you're done, you'll just hit submit and turn it in. But double check that you filled out all of the boxes in complete sentences. Only slide without is going to be slide 17, where it asks for just a list. The rest of the slides should be complete sentences for all 19 slides.